Hello, hello. Am I audible? Can you please let me know in the chat?
Yes, you are audible.
And is my screen visible?
Yes.
Okay, thank you.
Yes.
So, good evening, everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. This is my second live session, and in this live session we will discuss some practice problems on week 2 topics, which were mostly linear regression and subset selection, principal component analysis. These were the topics that were covered in week 2, so we will discuss some practice problems on these topics. And if you have any questions or queries, please feel free to ask me during this meeting. Okay, so we will start solving some practice problems, and then if you have any questions or queries, then you can ask me later on. So this is the first question. Given a training dataset of 10,000 instances with each input instance having 17 dimensions and each output instance having 2 dimensions, the dimensions of the design matrix used in applying linear regression to this problem is. So what should be the dimension of the design matrix? Where each input instance is having 17 dimensions and each output instance is having 2 dimensions. So those who might not remember, design matrix is the capital X that has been mentioned during the video lectures. That is the capital X. So what are the dimensions of the capital X if we apply linear regression to this data? You can write your answers in the chat. I've got one answer in the chat. Shubham Arora is saying option B, which is 10,002 cross 17. Okay. P Karthikeyan is also saying option B. Ankit Srivastav is saying B. Dhruvi Sudhar is saying B. Sashi Kumar is saying C. Sharan Kumar Kanike is saying A. Juhi and Manoj are saying B. Shreya Hazare is also saying B. So most of the answers in the chat are option B. I got one option as C and one student is saying A. Hars Nerkar is saying C. Amit Malik, you have raised your hand. Do you want to say something? VG Satish is saying A. So most of the answers in the chat are option B. The correct answer is option C. 10,000 into 18. So design matrix, as I have said during the question, that design matrix is this capital X matrix that we use in linear regression, and each input instance is having 17 dimensions, and each output instance has 2 dimensions. But X consists of just the input. So and Y is output, capital Y, but we are not bothered about Y. So whether each instance has 2 dimensions or 1 dimensions, we don't really care about that. What we care about is this each input instance having 17 dimensions. So 17 dimensions or 17 features are there, but we have to add one intercept dimension, which is 1 for every input instance. We have to add that as the 18th dimension. So it becomes 18 columns in the design matrix, and there are 10,000 instances, so there will be 10,000 rows and 18 columns. So that's why the answer would be 10,000 into 18. That will be the design matrix or the X matrix here. Is there any doubt in this question? Because most of you have.
Sir, can you please explain once again?
Yeah, so there are 10,000 instances, and each instance has 17 dimensions, or basically 17 features or attributes, as we say. And X contains n number of n number of instances. So these are the number of instances. This is 10,000. And how many columns? So 17 plus 1. 17 are these are the number of features. 17 is the number of features, and 1 is the intercept column that we have to add for every instance. That is also discussed in the video lectures, that you have to add one intercept column for every data point. There would be just one for every instance, but you have to add that. So that's why total 18 columns would be there in the X matrix. So it would be 10,000 into 18. Is there any other doubt in this question?
Is it the extra one which is present, right? Is it because of addition of a target class?
Yeah, so like if the model is y equals beta 0 plus beta 1 x1 plus something like that. So this beta 0 is the intercept. So the beta 0 into 1. So this 1 is the intercept, and beta 0 is the coefficient of the intercept. So in the data the data does not contain this intercept, but we have to add this intercept 1 for every data points, so that we can get this intercept coefficient beta 0, which is very important for the modeling, because y equals beta 0 plus beta 1 x1 plus beta 2 x2. So to get this beta 0, we have to add this one extra column containing all ones only.
Okay, got it. Thank you.
Moving on to question 2. Which of the following is false about PCA? False about PCA, you have to find out. So there are 4 options. PCA is a supervised method. It identifies the directions that the data have the largest variance. Maximum number of principal components is less than equal to number of features. All principal components are orthogonal to each other. So which of the following is false about PCA?
आईडी बोल दी तो बोली बना तो बोले आईडी तो हाँ ये पूरा आईडी तो आप की भी है ना आईडी लगा बात नहीं करेंगे उधर तो इसी नौकरी करेंगे Mari.
Ankit Srivastav is saying option A. Anyone else? You can write your answers in the chat. Manish Kumar is saying A. Harsha Kushal is saying option B. VG Satish is saying option C. So the correct answer is option A. PCA is a supervised method. PCA is an unsupervised method, so it does not consider the output variable or y, as we said. So it does not consider the y variable at all. It only considers the input features or the x matrix here. And this is the only false option. The other options are it identifies the direction that the data have highest variance. So that is the actual objective of PCA, that it tries to find out the direction in the data points which has the highest variance. And option C says maximum number of principal components is less than or equal to number of features. This is also true. PCA is used to reduce the number of features, so number of principal components would be lesser than or equal to number of features. And option D says all principal components are orthogonal to each other. This is also correct. All the principal components are orthogonal to each other. The algorithm is built in such a way that it satisfies this orthogonality constants for each of the principal components. So option A is the only correct answer here. Now question 3. This is on KNN. Given below is your data set. So this is the data set which contains two input features, x1, x2, and y is the output variable. So you are using KNN regression with k equals 3. What is the prediction for a new input 3 comma 2? So this 3 comma 2 is the new input point that you have, and you have to predict the output value for this new input 3 comma 2 given this data set, this data table that you have x1, x2, and y, and you have to use KNN regression with k equals 3, and you have to use Euclidean distance measure to find out the closest points. Lavanya is saying option C. Forum Patel is saying option D. VG Satish is saying option D. Ankit Srivastav is also saying option D. Venu is also saying option D. So most of the answers in the chat are option D. So to solve this problem, what you have to do is that first, for this new point, you have to find out the three closest points. So knn with k equals 3 we have to implement. So basically for this new point 3 comma 2, you have to find out the three closest points from this data set. So this is the data set. So you have to use the Euclidean distance. So the first point is this 2 comma 5. So you have to find out the distance between 2 comma 5 and 3 comma 2. 3 comma 2 is our new point. So to find out the Euclidean distance, simply like this, root over 2 minus 3 square plus 5 minus 2 whole square. So this way you have to find out distance between this new point and all the other points. So second point is 5 comma 5, then third point is 3 comma 3. So that way you have to find out the distance between this new point and all the other points. Then you have to find out the three closest points based on these Euclidean distance values that you would calculate, and you have to take the average of the y values of the three closest points, and this is what you have to do. So it will be easier because there are only 6 points, and the values are also within a given small range, so we can just plot these points and it will be easier to visualize and find out the three closest points without even computing the Euclidean distance. So these green points are the training data points. So there are 6 training data points, and this red point is the new point 3 comma 2. So this is the x1 axis, this is the x2 axis. So y value is not represented in this graph because y value is not used to find out the Euclidean distance, only the x1 and x2 values would be used. So for this red point, we can see that these 3 green points are the closest points. So we just have to use the y values of these 3 points to compute the y value of the new point. We have to take the average of the y value of these 3 closest points. So these 3, so 2 comma 2, 3 comma 3, 4 comma 1, these are the 3 closest points. From the table we can find out these are the 3 points, and for these 3 points, for the 2 comma 2 point y value is 2, for the 3 comma 3 point y value is 3, for the 4 comma 1 point y value is 2.5. 4 comma 1, yes, 2.5. So 2, 3 and 2.5, we have to take the average of these three values. 2 plus 3 plus 2.5 divided by 3, that is 2.5. So that is the prediction for the new point, which is this red point here. So this is how you have to calculate the output for a new point in a KNN algorithm, in the KNN algorithm. So is there any questions or doubts?
So can you quickly repeat this thing? I just joined now. Can you quickly repeat this question?
So the question was that this is the training data set. X1, X2 are the two input features and Y is the output variable, and you have to use KNN regression with K equals 3. And
So you
question,
find the three nearest neighbors, and the input point is 3, 2. So x1 is 3, y1, x2 is 2. So
yes,
then you find the x1 closest to 3, which is 3 itself is there, no? Then you find the x2 closest to 2. So is that
I
how
mean
you
this
work?
3 comma 2 is the new point, so you have to find out the three closest points of this point 3 comma 2.
Okay.
So this is one point, this is another point, this is another point. So these are the 6 points, right?
Okay.
In a 2D plane, these are the 6 points, and you have to use Euclidean distance to find out the three closest points for the new point 3 comma 2.
Okay.
And you have to take the average of the y values of those 3 points only to get the
Got it,
prediction
got
for
it.
the.
Got it.
Now moving on to question 4. Find the mean squared error for the given predictions. So y is the true value and fx is the prediction. So for 6 data points, these are the target values and the predictions. So what is the mean squared or error or the MSE error for these predictions? Lakshmi, please mute your microphone, otherwise it is making some noise. Ankit is asking for how many dimensions can we use Euclidean distance formula. So the Euclidean distance formula can be used for as many dimensions as you want. In the previous question, we had only 2 dimensions, x1, x2. It can be x1, x2, x3, x4, x5, 5 dimensional or even 10 dimensional. Still you can use the same Euclidean distance formula. VG Satish is saying option A, Manish Kumar is saying option A, Foram Patel is saying option A. Okay.
So mean squared error will be like fx minus y the whole squared, right? For each
Yes,
of
sum over that. I mean, you have to take the average of that basically.
the average. So then it is 1 plus 1, 1 squared plus 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 1 squared divided by 6. So that is 1.
Yeah, so you're saying option A.
Yeah.
Okay, so yeah, A is the correct answer. So it would, the formula for MSE or mean squared error is summation over yi minus fxi whole square divided by n, I equals 1 to n. So in this case, these are the yi values, y0, y1, y2 up to y6, and these are the fx0, fx1, fx2 up to fx6. These are the values. So you just have to put these values into this formula. Like for the first data point it would be 1 minus 2 whole square, for the second data point it would be 2 minus 3 whole square, like this, and for the last data point it would be 32 minus 31 whole square divided by 6, and if you compute this it will be 6 by 6, which is 1. So correct answer is option A. Is there any doubt on this question?
No doubt.
Now question 5. Suppose we want to add a regularizer to the linear regression loss function to control the magnitudes of the weights beta. We have a choice between omega beta, which is defined as summation over I equals 1 to p absolute values of beta, and omega 2 beta, which is summation over I equals 1 to p beta square. Which one is more likely to result in sparse weights? So sparse weight means the weight, most of the weight values would be 0. Some of them would be non-zero, but most of them would be 0. And there are 4 options: omega 1, omega 2. Both omega 1 and omega 2 will result in sparse weights, and neither of omega 1 or omega 2 can result in sparse weights. Foram Patel is saying option A. Manish Kumar is saying option B. Anyone else? You can write your answers in the chat. Lavanya is saying option B. Harsha Kushal is saying option D. Shubha Marora is saying option B. The correct answer is option A, omega 1. So this one. So this is also called lasso regression, or L1 regularization. It is also called, and omega 2 is called ridge regression or L2 regularization. So it has been taught in the class also that this lasso regression, where we just sum over all the absolute values of the parameters beta, it drives the values towards 0 more often than this beta square. So this because of this absolute value, it tries to drive the values towards 0 much more than the omega 2. Omega 2 would also reduce the values of the beta, because that is the actual objective of a regularizer, that we want to reduce the magnitude of the parameters beta. That is why we do a regularization. So omega 2 would also reduce the magnitudes of the weights beta towards 0, but omega 1 will drive most of them to 0, and which reduces the number of parameters in our model, and that would be better in case of a really large data set and a large number of parameters. So that's why the correct answer here is omega 1 beta, which is called lasso regression. Yeah. Now question 6. Does anyone have any question? Question 6. The model obtained by applying linear regression in the identified subset of features may differ from the model obtained at the end of the process of identifying the subset during which of these selections? So there are 4 options: forward stepwise selection, backward stepwise selection, forward stage-wise selection, and all of the above. So if we the model obtained by applying linear regression on the identified subset of the features may differ from the model obtained at the end of the process of identifying the subset, in which of these subset selection methods that might happen. Forum Patel and Julia saying option C, Shubham Arora is saying option D. Purabi Chaudhary is saying option C. Any other answers? Orijit Saha is saying option A. Harsha Kushal is asking what are the lectures which we need to go through for understanding these topics. So all these topics, all these questions are from week 2 topics, regression and feature selection and principal component analysis. These were the topics taught in week 2, and all these questions are coming from those topics. So correct answer is option C, forward stage wise selection. So forward stage wise selection, in case of forward stage wise selection, what we do is that for every iteration or for every stage, we try to find out the feature from the remaining set of features that has the highest correlation with the output. And that way basically in every stage we are having an univariate regression on the output. So in case of forward stage wise selection, in the process of selecting the features, we are actually creating a model or training a linear regression model But in case of the other methods like forward stepwise or backward stepwise selection, we are not creating any model. Basically we take one in every iteration we take the next feature, and we try to add it to our already built subset of features, whether it would increase the accuracy or not, or improve the performance of the model or not. If it improves, then we will add that. If it doesn't improve, we will remove that. So this is how forward and backward stepwise selections work. So these two methods for subset selection do not create or train any linear regression model, whereas the forward stage-wise selection actually creates a linear regression model, but which might differ from the model that will be that we might get after training on the identified subsets after the feature selection. So those two models might be different. So option C is the correct answer. Is there any questions or doubts?
Can you just repeat, like, what is forward stepwise selection, what is backward stepwise selection, what is the meaning of forward stage-wise selection?
Okay, so I mean these topics have been covered in week 2 video lectures. So in brief, forward stepwise selection is basically these are subset selection methods. So we don't want to keep all the subsets, we want to keep only a we don't want to keep all the features in the dataset, we want to reduce the number of features. So in forward stepwise selection, we start with empties, one empty set, then one by one we keep on adding one feature to the set if it improves the accuracy of the model or performance of the model. So greedily we keep on adding one feature after the other if it improves. And in backward it is exactly the opposite. So we start with all the features first, and we keep on removing one feature after the other if it improves the accuracy, or it if it does not fall below a certain cutoff for the accuracy. And in forward stage wise selection, this is different from the other two. So in forward stage wise, in every stage or basically every iteration in this algorithm, we pick the feature which has the highest correlation with the output data. So basically in every stage we are having one univariate regression on the output y. So basically in every iteration we are forming a model, we are continuing to form a model, linear regression model. So which is not the case for the other two selection methods. So it would be much clearer if you go through the video lectures again about these subset selection methods. So in forward stage based selection, we are actually creating a model while finding the subset features. Question 7. Consider forward selection, backward selection, best subset selection with respect to the same dataset. Which of the following is true? Best subset selection can be computationally more expensive than forward selection. Forward selection and backward selection always lead to the same result. Best subset selection can be computationally less expensive than backward selection. Best subset selection and forward selection are computationally equally expensive, and the last option is both B and D. Nazdin is asking, are your last session recording uploaded? Yeah, so last session recording is already there in the course homepage. There is one tab called live sessions, and from there you can get the YouTube video links. Indu Atri is saying D. Abhijit Shah is saying C. Forum Patel is saying B. So the correct answer is option A, which is best subject selection can be computationally more expensive than forward selection. So we are considering three subset selection methods: forward selection, backward selection, best subset selection. So for the first two methods, forward and backward subset selection, these two methods are greedy methods. So these two methods are not guaranteed to produce the best subset of features, because we are greedily keep on adding or removing features in these two algorithms to get the final subset of features. Uh, but the best subset selection method, in this method, every possible subset of features is considered, then it compares all the subsets possible for all the features, and then it only keeps only the subset which has the highest accuracy. So if there are m features, so 2 to the power m minus 1, these are the number of subsets that are possible, which can be huge if m is very high. If m is 20 or 30, this 2 to the power m minus 1 would be very high. But this is what this best subset selection method tries to do. It goes through all the possible subsets. There are 2 to the power m minus 1 number of possible subsets. It goes through all possible subsets and tries to find out which is the best performance among all. But this forward selection and backward selection is just one run through the set of features. So if there are m features, it would take only m iterations. But if there are m features, this best subset selection would take 2 to the power m minus 1 iterations to compute this. So best subset selection can be computationally more expensive than forward selection. So that's why option A is the correct answer, that in case of best subset selection, it goes through all possible subsets and then finds out which is the best. But in case of forward and backward selection, these two are greedy methods. So it just goes through all the subsets, all the features only once to decide whether to keep it in the subset or not. So is it understandable? Is there any doubt?
Clear.
Question 8. Principal component regression is an approach to find an orthogonal set of basis vectors which can be used to reduce the dimension of the inputs. Which of the following matrices contain the principal component directions as its columns? Following the notations from the video lectures. So all the matrix notations that were used, you have to remember those notations. So which matrix contains the principal component directions as its columns? X, S, X, C, V, U. These are the options. Forum Patel is saying option E, which is U. Any other answers? Shruti is saying option B, which is S. Harsha Kushal is saying E, which is U. Correct answer is option D, which is V. So if you have followed the video lectures, you remember that in principal component analysis, X is decomposed into U D V transpose. So this is called singular value decomposition, and D is a diagonal matrix. So only the diagonal elements are non-zero, other elements are all zeros, and this V is the matrix which contains the principal component directions. So that's why D is the correct answer. I mean option D, which is this matrix V, is the correct answer. V contains the principal component directions as its columns. Question 9. Let A m cross n be a matrix of real numbers. The matrix A transpose has an eigenvector x with eigenvalue b. Then the eigenvector y of A transpose A, which has eigenvalue b, is equal to. There are 4 options for B. Vaishnavi is saying B, Lavanya is saying A, Puravi Chaudhary is saying B, Nazneen is saying B, Indu Atri is saying B. Sharan Kumar Kanike is saying A. Dhruvi Shutar is saying A. Forum Patel is saying option B. Shruti is saying option B. So to solve this problem, we have to first write this eigen value formula. So what is given is this: for the matrix A transpose, X is the eigenvector and B is the eigenvalue. So we can write A transpose X equals B into X. So this is from the formula for eigenvectors and eigenvalues. Now we have to find out the eigenvalue for A transpose A. So the eigenvector of the matrix A transpose A. For that we can simply multiply this matrix A transpose to both the sides of this equation. So this is what we get. Now we just rearrange these terms. So we get this. So this is the matrix, actual matrix, and these are the eigenvectors A transpose X, and B is the eigenvalue. So for this matrix A transpose A, this is the question, that for this matrix A transpose A, you have to find out the eigenvector for which the eigenvalue is B. So for this matrix A transpose A, the eigenvalue is B. In that case, the eigenvector is A transpose X. So option B is the correct answer. Option B is the correct answer. Yeah. Is it understandable?
No, how is option B the correct answer? Like we got that A transpose X is equal to.
Okay, so this is the vector formula for the matrix A transpose, right? A transpose X equals Bx. Is it fine?
Yes, yes, yes.
Then we multiply A transpose to both the sides.
Yes, got it.
Then we just simple rearrange this A transpose X. We just rearrange this matrix.
Okay.
So from there, so this is the matrix for which we want to find out. This is the matrix.
Yes, 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 yes.
So this and B is the value that is already present in this equation.
Right.
This, so that means these A transpose X is the vector.
Yeah, yeah. Okay. Correct, correct.
Now question 10. Let U be a n cross 1 vector such that U transpose U equals 1. Let I be the n cross n identity matrix. The n cross n matrix A is given by I minus k U transpose, where k is a real constant. U itself is an eigenvector of A with eigenvalue minus 1. So what is the value of k? So you have to again start with the eigenvector formula for the matrix A, and from there you can find out the value k. Nazneen is saying option C, which is 2. Indu is saying option B. Vaishnavi is also saying option B. Harapriya Kaur is saying option C. So for this question, again you have to start with the eigenvalue formula. For this matrix A, U is the eigenvector that is already given. So A U equals minus 1 into U. Minus 1 is the eigenvalue that is also given. So minus 1 into U, and A is given by I minus k U transpose. This is also given in the question. So now we can substitute the value of A, which is I minus k U transpose into U equals minus U, Now we just have to rearrange these terms again. Ku u transpose u equals minus u. So this u transpose u is 1, which is given here in the first line of this question. So u minus k u into 1 equals minus u. So from here we can write ku equals 2u. So k equals 2. So option C is the correct answer. Now question 11. Bias and variance can be visualized using a classic example of a dart game.
Sir, what is the answer of the previous question?
Option C, 2.
Yeah, thank you.
Bias and variance can be visualized using a classic example of a dart game. So in dart, you throw arrows towards a circular target. We can think of the true values of the parameters as the bullseye on a target, and the arrows values as the estimated value for each sample. Consider the following situations and select the correct options. So 4 boards are given here, basically 4 different methods for 4 different players. So you have to find out which player has lower variance and which player has high bias. So these are the different options given. 3 options are given. So player 1 has low variance compared to player 4. Player 1 has high variance compared to player 4. Bias exhibited by player 1 is lesser than that done by player 3. Ankit Srivastava is saying option B. Lavanya is saying option B. Okay. Prince Kumar is also saying option B. Dhruvi Shutar is saying option B. So the correct answer is option B. So most of you have written option B in the chat. So for the player 1, we can see that bias is high. Bias is basically the error, how much it is off from the target. So all the shots are very much off from the target or the bullseye. So bias is high and variance is also high. The estimated values are very much scattered around the board, not concentrated within a small region. For player 2, for this player 2, we can see that the bias is low because the estimated values are close to the target, but the variance is high. The estimated values are very much scattered across the board. For player 3, both bias and variance are very low, because bias is low because the estimated values are almost same as the target values, because almost all the points are bullseye. So bias is low and variance is also low because it is concentrated within a very small region. So bias and variance both are low. And for player 4, bias is very high, the error is very high, it is very much off from the target. So bias is very high but the variance is low. So analyzing all 4 boards, we can see that player 1 has a higher variance compared to player 4. So option B is the correct answer. Rijit Shah is saying repeat So
Can you please explain bias and variance once again?
so bias basically means the error, how much your prediction is differs from the actual values. So and variance is how much your predictions are uh, varying for different predictions, whether they're all the predictions are almost same or they are varying a lot. So for player 1 we can see that the estimated values are very much off from the target, so bias is high, and variance is also high because all the points are scattered throughout this big region, so variance is also high. So similarly player 2 has low bias and high variance. Low bias because all the estimated values are very much near to the target, so that's why error is low, bias is low, but variance is high. Similarly for player 3, variance is low, it is concentrated within this red region only, and bias is also low, error is very low, so bias would be low. And for player 4, bias is high because the points, the estimated values are not anywhere close to this red region which is our target, so bias is high, and variance is low because it is the points are all concentrated within this small region. So this is how you can analyze whether the bias is high or low, or the variance is high or low. Question 12. Which of the following are true for any m cross n matrix A of real numbers? The row space of A is the same as the column space of A transpose. The row space of A is the same as row space of A transpose, and the eigenvectors of A transpose are same as eigenvectors of A transpose A. The eigenvalues of A transpose are the same as eigenvalues of A transpose A. Multiple options may be correct in this question.
A is there.
Okay, A, yeah, and some other options might also be correct. Forum Patel is saying A and D. Okay. Anyone else? Indu is saying A and C. Shruti is saying C only. Rakhi is saying A and D. Vijay is saying A and D. Nehan is saying A and D. LD Lingam is saying A and D. So most of the answers are A and D. So option A is obviously correct, that the row space of A is the same as column space of A transpose. That is the definition of transpose, that rows become columns, columns become rows. So option A is certainly correct. Now for the eigenvalue and eigenvector for A transpose. So A transpose into X equals, let's consider B into X. Now so from this, if we multiply A transpose to both the sides, so from here we if we rearrange the terms a little bit, we get A transpose A, which is what we need, and A transpose X equals B A transpose X. So A transpose X is the matrix, B is the eigenvalue, and A transpose X is the eigenvector. So B is the eigenvalue for A transpose A and also A transpose. So eigenvectors might not be same, but eigenvalue is certainly same. B is the eigenvalue for both A transpose A and A transpose. So option D would be correct. So A transpose A, this A transpose A might not be same as X. So that's why eigenvectors might not be same. But B is obviously present in both the cases for A transpose and A transpose A.
Sir, can you repeat from the third step, that is A transpose into A, then A transpose X is equals to B into A to the power of, means A transpose X. So can you repeat that?
Yeah, so after we get this, so A now if we analyze this equation, it is similar to any eigenvector equation. This is the matrix A transpose A, B is the eigenvalue because it's a scalar, and A transpose X, this is the eigenvector. So B is the eigenvalue for A transpose A, and A transpose X, this is the eigenvector for A transpose A. So B is the eigenvalue which is same as this B here, and B was the eigenvalue for A transpose. So that means eigenvalues for A transpose and A transpose A are same. But the eigenvector, so eigenvector for A transpose was X, but eigenvector for A transpose A is A transpose X. So these two might not be same, X and A transpose X. These two might not be same, but the eigenvalues are same in both the cases, which is B here. Is it okay?
Thank you, sir.
Okay.
Eigenvectors might not be same.
Yes.
The eigenvector in this case is A transpose X.
Yeah, previously it was X for A transpose,
Right,
and
got
for
it.
the new matrix is A transpose. So these two might not be same, but the eigenvalue is B in both the cases. So eigenvalue is certainly same. So A and D, these are the A and D, these are the two correct answers. Yeah, so these were the problems that I wanted to discuss in this live session. Now if you have any questions regarding any of the questions, you can ask me.
Sir, can you share these questions to us?
Yeah, all these PPTs and the video lectures would be uploaded, and you can get the links from the course homepage. There is a tab called live sessions or something. There is a tab in the course homepage. There all the links are there.
Okay,
Will
thank you.
this video session be recorded?
Yes, it is being recorded, and after that I will upload it in YouTube and also share the link in that sheet. From that sheet you can get that. So the in the live sessions tab, all these links would be present.
Could you just quickly go through questions 1 through 4, questions 1 through 3?
The question 1 was that for 10,000 instances, if you each input instance has 17 dimensions and each output instance has 2 dimensions, then what is the dimension for the design matrix or the X matrix? X is called the design matrix or the input features matrix. So what would be the dimension for X? So 10,000 instances and each input instance has 17 dimensions. So it would be simply 10,000 rows and 17 plus 1 columns. So 10,000 into 18 it would be.
That plus 1 comes from where?
Plus 1 is the intercept. So in the model looks like y equals beta 0 plus beta 1 x1 plus beta 2 x2, like this. It will continue like this. So this beta 0, so this is the intercept coefficient. So beta 0 into 1. So this 1 is this intercept and beta 0 is the coefficient for that. So this 1 will not be present in the input data, so that's why there are 17 dimensions. So you have to add this intercept 1 for every instance, so that's why it becomes 18 dimensions or 18 columns in the data. So x1 x2 are the actual features that will be present, but this 1 will not be present, so you have to add this 1 as one extra column in the data, so that's why it will become 18 columns.
Right.
And the second question was very simple, that which of the following is false about PCA. So PCA is a supervised method, which is certainly false. PCA is an unsupervised method, and other options are all correct about PCA. And third one, yeah, I already explained you doing that.
So I thought PCA was part of linear regression. That's not the case, right?
No, PCA is principal component analysis. It is to reduce the number of features in the data. So we only consider the principal components, not all the features. So it is to reduce the number of features. So it is an unsupervised method. So it is also covered in week 2. So if you go through the video lectures, you'll be able to understand.
Sir, that question number 3, can you please repeat again?
Yeah, in question number 3, you have to apply KNN with k equals 3 for a new data point 3, 2, and this is the data set that is given to you. X1, X2, these are the two input features, and Y is the output variable. So there are 6 data points here. So for this new point 3, 2, for this new point 3, 2, you have to find out the 3 closest points and then take the average of the y values of these 3 closest points. So if you just plot it, it will be easier to understand. You can also use Euclidean distance method to compute the distances. So
sir, after Euclidean distance, we have to calculate the mean of the nearest point, right?
yeah, so 3 closest points, yeah. 3 closest points, and take the average for of the y values of those 3 points.
So average should be taken for the 3 point or
No, only
for the
3
y
points.
value?
Only 3 points. I mean, y values of the 3 points.
Oh, y values of the 3.
Why not? I mean, you have to find out the y value for the new point. So obviously, you will take the average of the y value of those 3 nearest points.
Okay, okay.
So, will you explain question number 5 from assignment 1?
Assignment 1 is not over yet. The deadline is not over yet.
Yeah, some similar kind of questions. If you
Question 5, what was this?
it was like
Was it on KNN or on regression?
it is on the linear regression. Some y equation was given like
Yeah, y, I remember, y equals beta 0 plus beta 1 x1, and the second one was beta 1, beta 2, beta 3, I think. No, beta 0, beta 1, beta 2, 3 terms. Yeah, I mean, that there is no similar question for that.
yeah,
That is,
and we have given 2 points.
no, I mean, the assignment.
How to solve question actually? So what is the strategy to solve the question?
If you have any doubt regarding the question, you can ask in the discussion forum, but that it would not be very good if I discuss it before the deadline is over. So it is better if you have any doubt regarding that question, you can ask in the discussion forum. The regular TAs would be able to resolve your doubts regarding that, but obviously they will also not tell you directly how to solve that question, because the deadline is not over yet.
Okay.
Sir, how will you define a good classifier if the data set is small?
Define a good classifier. I mean, you have to experiment with different classifiers, and whichever classifier has highest accuracy, that would be a good classifier. Otherwise, it depends on what kind of data set it is, what is the actual task, in what domain. So all these things matter. So you cannot directly say it's a small data set, so apply this. So you cannot directly say anything like that.
When working with a small data set, one should prefer high bias, low variance classifier over low bias, high variance classifier. Is it true?
For a smaller data set, I mean, the trade-off between bias and variance is also dependent on the task. Whether you want to keep the bias low, I mean, this depends on the complexity of your model. If the model is very complex, then bias might be low, but variance would be high. Otherwise, the opposite might happen. So it's not possible to exactly define that for smaller data sets, this would be the correct way to go. So there is no such thumb rule for that. I mean, at least I'm not very sure about that.
So we have a question, and the choice is like that. And from this, we have to choose the correct answer. Choices are
If
then
if it is in the question, then certainly I cannot answer that right now. If in the assignment the exact thing is written, then I cannot answer it obviously. But I don't, I have not seen the question properly. But it would not be right to answer this now. It, you have to answer those questions on your own, and if you can't do it after that, the questions will be, the solution would also be uploaded and you will get to know the answers. But before the assignment deadline is over, I cannot discuss that.
So when after the deadline, the way we can get the answers of assignment one, is it will be uploaded
Yeah,
on the
generally from the NPTEL, those solutions are uploaded there in the course web page. Generally, it is done. So you should get that after the deadline is over.
okay, sir. Thank you.
Ankit Srivastav is saying bias and variance. Okay, so in that question, I already explained it 2-3 times. The bias is basically the error, how much your prediction is different from the actual target value, and variance is how much it is spread out. So whether your predictions are always concentrated within a small region or not. If it is not, then the variance is high. If if the prediction values are almost same, then the variance is low, and bias is high when your estimated values are very much off from the target, very much different from the target, then bias is high. Bias is basically error. Is there any other questions or queries?
Sir, actually, I joined from last Monday. So how I answer the assignment within tomorrow? Actually, we have no other provision to complete the assignment within tomorrow. We have to complete the assignment within tomorrow.
Yeah, if the deadline is tomorrow, then obviously you have to complete it by tomorrow, otherwise it would be incomplete and you will not get any marks for that. So if the deadline is given tomorrow, then certainly it is tomorrow. And also the questions are not very lengthy, questions are very small, and there are only 5-6 questions in one assignment, so it will not take much time. If you can go through all the video lectures properly in time, then answering these questions would not take a lot of time.
Okay.
If there are no other questions or queries, then we can end this live session here. Thank you everyone for joining.
Thank you, sir.
Thank you.
Thank you, sir.
thank you, sir.
Thank you.